We can use the language of calculus, specifically limits, to talk about types of discontinuities, removable versus non-removable. And you should remember this from algebra. So if you have a rational function, r of x, which can be written as p of x divided by q of x, right? There's a quotient there. It's a rational function. And if I have a root xi of q of x, so that just means that q at xi will give me a zero, right? A root is a zero. Well, if it's also a root of p of x, then I will have a removable discontinuity at that point. So for instance, x minus 2 over x minus 2. Now, your knowledge of algebra says that this is just always going to be equal to 1, right? Because it's x minus 2 over itself, x minus 2. But it's only equal to 1 when x is not equal to 2. Because remember, as soon as you write that down, x cannot be 2 anymore. So this function actually is just constantly equal to 1, except when you get to 2, it doesn't exist. You have a removable discontinuity right there. The limit will exist even though the function does not. Now contrast that to in the case where you don't have a root of the numerator. So if you have a root of the denominator but not the numerator, it's called a non-removable discontinuity. So a good example there, take 1 over x. Right? This has a root of the denominator. If x was 0, then it would make my denominator 0. But obviously, if x is 0 here, it doesn't give me a 0. So it's a root in the denominator, but not a root in the numerator. And here we have a non-removable discontinuity. So it's the exact same thing what you learned in algebra, except now you can talk about it using limits. If you have a root, top and bottom, it will be a removable discontinuity. It will appear as a hole in the graph, and the limit will exist. If you have a root in the denominator, but not a root of the numerator, then you have a non-removable discontinuity, and the limit will not exist.